we're going to start a new unit. This is math modeling. This is kind of like a combination of all of the stuff that you've learned this year, plus a little bit extra. So this is the first thing that we're going to come in contact with. This is a linear equation. Okay, so like this is the first thing that you learned about like lines, graphing, the whole like function thing. Okay, so with that being said, these are the key words that will help you in order to create equations, because our goal today is to create equations. Okay, based off of problems. Yeah. All right, so on this one, I don't want you to write down the entire thing. I want you to tell me the important pieces, and we're going to write that information down. So it says, Stephen belongs to a movie club in which he pays an annual fee of $39.95. And then he rents DVDs for 99 cents each. In 1 year, Stephen spent $55.79. How many DVDs did he rent? So important pieces are the fact that his name is Stephen, okay? And then, what else is important? Okay. Annual fee of $39.95. Okay, and then what else is important? 99 cents each. And then how much he spent?
In 1 year.
Okay. All right, and then what else? Okay. All right. So there are 4 things that you will write down on your paper. Your initial fee, right? And so you're going to say that's $39.95, okay? And then you're going to say 99 cents each. So that's kind of like cost per DVD, right? Yeah. This is also known as like slope, right? All right, we're not there yet. Nope. Okay. And then you've also got how much he spent in total, right? So like total amount, right? So that's going to be that $55.79. And then our question is, how many did he rent, right? Okay, so this is what you should have written on your paper. Probably have already figured out how we're going to set this up, okay? But I want to talk through it. So how do we know that this is a linear equation? Like,
because 99 doesn't change.
99 doesn't change. Okay, so Pat's talking about the fact that there is that 0.99 cents, right? Per movie, right?
Sure.
Yes? So that's going to be our slope, right?
Sure.
So in that y equals mx plus b? Yes, no, maybe? That's your m, right? Okay? What about your initial amount? How much is that?
That's $39.95.
$39.95. Okay? So if I were to write an equation for this, it would be y equals 0.99x plus $39.95, right? Okay? Now, what does this $55.79 come in?
The Y.
Okay, so I'm going to plug that in for my y, right? So I'm going to have 55.79 plugged in for my y. Did everybody see where I got that?
Yes, ma'am.
Okay, so I'm going to ask this question again. How do we know that this is a linear equation without me having to tell you that? Because of the slope. The slope is constant, right?
Yeah.
So for linear functions,
It goes like the same.
slope is constant.
Yeah.
All right?
So it'll be like a straight line, right?
Yep.
Diagonal.
It'd be a straight line. Now, I want you to take a moment. I want you to actually solve this equation out. Okay? So, y'all are telling me that it's going to be 16 because you subtracted 39.95 from both sides and then divided by 0.99, right?
That's not how I
That's not how she got it.
Oh, God, that's how I got it.
You did what?
She multiplied 16 by 99.
No.
Got
Okay.
you
You
negative.
know what I got?
When you solve this, you got x equals 16. What does that x equals 16 represent? How many DVDs that he bought, right? Or how many he rented. Okay? So let's go ahead and talk about the next one. So again, I don't want you to write the whole problem down. We're going to highlight the key important things, and then we're going to go from there. So for her cellular phone service, Vera pays $32 a month, plus 75 cents for each minute allowed over the allowed amount
$32 is the
in her plan. Vera received a bill for $47 last month. For how many minutes did she use her phone beyond the allowed minutes? Okay, so how are we going to set this equation up?
32 is the
All right, shh. 32 is the initial cost, right?
and the slope is the same of the cent. Yeah.
Okay. Slope is the 75 cents
And
per minute.
47 is the Y.
And then 47 is going to be the y. Okay? So, Renaya's already told me that it's going to be 47 equals 0.75x plus $32. Okay? And what are we actually solving for? What does x represent? How many minutes, right? Okay? So, we're going to solve for x. We're going to subtract 32 from both sides. 15 equals 0.75x. We're going to divide by 0.75 on both sides.
20, so she said 20, I'll go with 20.
Okay. So x is going to equal 20. So Tina sold cookies at her club's bake sale. She spent $18.50 on supplies. She sold her cookies for 75 cents each and made a profit of $24.25. How many cookies did Tina sell? All you're going to do is write down the important information. You're going to write the equation and go ahead and try to solve it on your own. So how do I know that this is a linear equation? How do I know this is a linear equation?
Because it's constant. 75 though.
Okay, because this 75.
When you see each, it's always constant, right? Ooh, you probably like that.
All right, so yes, that 75 cents each is a constant. That does mean that we got a slope. So now we're going to write an equation. So we're going to say y equals, and y'all already told me that 0.75 is my slope, plus 18.50. Okay? And when you have this y right here, you're actually going to plug in that 24.25 because that is your profit, right? So, because when she's got a profit, you got to take out how much you spent on supplies, right? So, if I'm trying to figure out x, which is how many cookies did she sell, I'm going to subtract 18.50 from both sides. And then I'm going to get 5.75 equals 0.75x.
Divide by 0.75.
I'm going to divide by 0.75 on both sides. And then y'all are telling me that I'm going to get 7.6 repeating. Now, here's my issue. Can you have half a cookie?
No.
Like, can you buy half a cookie?
So it's
Like, you shouldn't, okay? You should not. Okay? All right? So, here's the deal. If I put, y'all, this is real important, because this is going to be on your SAT, because they're going to ask something like this, okay? Now, if you put 8, that's over her profit, okay? So, you can't say it's 8, okay? If I plugged 8 into here, that would be over her profit. She can't make more money than she did, right? Like, that doesn't work. So, it's going to be x equals 7 cookies, okay? Because we can't have half a cookie, right? Like, she can't sell half a cookie. So, it's going to be a profit of $24.25 based off of 7 cookies.
How
Yeah.
would you know when to round up, round down?
It kind of just depends on what the problem asks for. So, like, in this instance, if I would have rounded up to 8, somebody in their calculator really quickly plug in 8 into this equation. So, if you did 0.75 times 8 plus 18.50, what did you get? 24.5. Isn't that over our profit?
Yeah.
Well, then that's not asking how many cookies she sold. Does that make sense?
What if it's 7.5?
Again, same concept. Like, if you have any kind of decimal place, it's just like humans. You can't have half a human. Like,
Yeah.
realistically, you can't have. Huh?
Go back to the
Yeah. Okay. All right. Go ahead and take a moment. Write these 3 steps down. Okay. And really, this is just define your variables, identify your slope and your y-intercepts, and then write the 2 equations. Those are the things that you're writing down on your paper. Okay, so this says the Turbo Taxi service charges a flat rate of $5.40 per mile. Shh, I'm in the studio. Okay, the Express Taxi Company charges a flat rate of $2.75 per mile. Write an equation that describes the cost of each taxi cab in terms of miles and driven. Okay, so first things first, we got this Turbo Taxi, that charges a flat rate of $5 and then 40 cents per mile. So if I'm going to write the equation for this, I'm going to say slope, which is 40 cents per mile, plus $5. Because if you get in a car and you don't go nowhere, you're still going to pay $5. But if you get in the car and then you go like down the street a mile, it's going to add 40 cents per mile, right? So you
step in the car.
You step in the car, you get $5. $5. I mean, like, think about it. If you order an Uber and the Uber shows up, or you cancel the Uber, it costs you how much? I don't know. I don't remember. All right, it's like $5. Okay, so for like this purpose, $5. Okay. On this next one, the express taxi. Okay, they charge a $2 flat rate, and then they do 75 cents per mile. So they're a little cheaper on like the flat rate. Like if you jump in the car, it's like $2. But if you go any farther than like 3 miles, they're expensive. Okay. So that is how you write those equations. How did I know that those are linear?
It's a flat rate.
Per mile.
Okay. So that per mile. Okay.
Don't change.
Yep. All right. So then let's talk about this next one. Teresa was taking her 2 grandchildren to the zoo. Also, y'all are gonna get a copy of this, so don't like freak out if you don't get it all down. Okay. All right. Teresa purchased 1 adult ticket for herself and 2 children's tickets for $18.20. So let's just look at Teresa's life. We got 1 adult and 2 children, and she paid $18.20. She got a big family. It's fun. Okay, so let's assign these tickets a variable. So adults are gonna be A, and children are gonna be C. Okay, so we have 1 adult ticket and we have 2 children tickets. For how much did they spend? Okay. Now, this looks a little different from what the other equations look like, right? Okay, like it's not y equals mx plus b format. However, this is still a linear function. Let me say that again. This is still a linear function. If I solved for one of these variables, it would be a linear equation, right? Yes, no? Okay, all right. Go ahead and take a moment and try to write an equation for the family of 5. Take a moment. So, Renaya said that is going to be 2A, 3C
equals $30.90.
Boom. Now, eventually this week, we're going to get to the point where we're actually solving for this mess. So we're going to do elimination, substitution, and graphing. These are 3 words that we haven't heard in a while, right? Okay, they're the 3 words that probably haunt your dreams. Yeah? Okay? So, let's go over the last problem. A salesperson that worked at a cell phone store recorded the following information about the number of Android and iPhones that he sold for the day. He sold a total of 24 smartphones that were either an iPhone or an Android phone. Let's stop right there. Ready? So you've got 24 total smartphones. If I were to ask you, like, how many iPhones did he sell out of the 24? How would I write that equation?
What'd you say?
Okay, so if I have 24 total smartphones, and I wanted to figure out how many, like, individual, like, hey, I had 12 iPhones, hey, I had 6 Android, whatever, how would I write that equation for that one?
All right, how about this?
I'm ready.
24A. Wrong. All right, try it again.
Okay, so, like, if I had on my desk, I tell you I have 3 markers, right? Okay, I got 3 markers on my desk. I want to know how many of each color I got. Well, I got 3 different types of ones, right? So I would say like 1 P for 1 purple, right? I would say 1 green for like 1 G for green, and then I would say 1 yellow for that. Now if I had, imagine with me, okay? If I had 4 markers on my desk, but I had 2 green, I'm going to say 2G plus 1P plus 1 yellow equals 4 markers, right?
So 1A.
1A, so A
So 1
plus,
or 1A. Oh,
because I don't know how many, right?
I equals 20. Equal S.
Plus, equal, where did S come from, baby?
I was thinking.
Oh, okay, equals 24.
All right.
So,
It's 150.
Android
It's 200.
plus, hang on. Android plus iPhone equals 24, right? Do we see where I got that from? I took the total amount, and I took each part, and I said this plus this equals the total amount, right? Okay? Now, total sales, they told us that $200 per iPhone, right? And then they told us $150 per Android, and the total was $4,150 in total for the smartphones. So this is going to be 200 for the iPhone, which is P, 150 for the Android,